Kangaroos are some of the oddest yet most endearing mammals on the planet today. Aside from humans, they are the only mammals that move on two legs, with their unique spring-loaded hopping hind limbs, allowing them to travel great distances across the dry wilderness of Australia in search of plants. Whilst today they are peaceful herbivores, well, sort of, the fossil record shows they had a more sinister past. In this video, we're going to explore the origins of the kangaroos, as well as many of their closest marsupial relatives. Mammals can be broadly divided into three groups based on their method of reproduction. The monotremes lay eggs. The placentals provide oxygen and nutrients to a developing fetus internally with the temporary placenta organ. And lastly, the marsupials, which give birth to undeveloped young that grow and nurse within their mother's unique pouch. Whilst marsupials first evolved in the Americas close to the extinction of the dinosaurs at the end of the Cretaceous period around 66 million years ago, they later dispersed to Australia in the Eocene epoch about 55 million years ago, as it and South America were both connected to Antarctica at the time. Once Australia rifted from Antarctica at the end of the Eocene, roughly 34 million years ago, the marsupials went on to dominate the now isolated continent, diversifying into a variety of forms. Whilst there are many kinds of small carnivorous species, by far the most famous of the marsupials are the members of the order Diprotodontia. They are named for their two front teeth, huge incisors found in all species, with almost all being for biting through plants, with some exceptions which we'll get to. The oldest known diprotodont fossils were found in the rocks of the Riversley World Heritage Site in Queensland, the oldest sediments of which date to the late Oligocene epoch, roughly 25 million years ago. They would have lived alongside many other marsupial species in what was a tropical rainforest, as Australia's climate was much wetter at the time, as was the entire planet. As Antarctica drifted over the South Pole over millions of years, it began to freeze over and alter ocean currents, dropping global temperatures and drying out the climate, culminating in the Ice Age around 2.5 million years ago. Whilst Australia was too equatorial for ice sheets, the drying climate caused rainforests to decline, giving way to open country and a vast central desert. Having been deposited over a period of around 20 million years, the rocks of Riversley record Australia's climate changing over geological time in how the plants and animals gradually changed from rainforest species in older sediments to those adapted to arid environments in the youngest rocks. A good example of this is the first diprotodont family we're going to look at, the Phascolarctidae, the koalas. Today, there is only a single species left, that of course being the koala, Phascolarctos cinereus, also commonly called the koala bear, with their scientific name even meaning pouch bear. Their teddy-like appearance is merely coincidence though, an example of convergent evolution, unrelated species evolving similar traits independently. Their bear-like appearance is in fact thought to be a direct result of Australia's climate becoming more arid. There are several different koala genera known from the early Miocene sediments at Riversley, dating from around 23 to 16 million years ago. One such example is Nimio koala, meaning excessive koala, after the complex appearance of its molars compared to the modern species. It's speculated that this was for feeding on a variety of plants. It's thought that the diverse range of plants in the rainforest habitat provided abundant food for many different species of arboreal browsers. Nimio koala's skull was much longer than the modern species, and had very large auditory bullae, hollow structures surrounding the inner ear which indicate that its ears were sensitive to low-frequency sounds, a useful adaptation for communicating in the vast, noisy rainforests, hence why modern adult male koalas make loud, low-frequency, pig-like noises that travel vast distances, acting as both attractors for females and to intimidate other males during the breeding season, and have large, teddy-like ears to detect them. Nimio koala was also slightly smaller than the modern species, and thought to have been more nimble and active. This would also mean they likely burned through their caloric intake faster, meaning they needed to feed more frequently. These more generalist browsers became extinct as the climate became drier and the forest plants they depended on disappeared by the late Miocene. by the Pliocene epoch around 5 million years ago, the first fossils of the genus Phascolarctos appeared, which includes the modern koala, P. cinereus, as well as the extinct giant koala, P. sturtoni, which became extinct in the late Pleistocene epoch, most likely due to the arrival of humans in Australia some 60,000 years ago, destroying their habitat with slash-and-burn agriculture, that is, using fire to clear vegetation for farmland, something very easy to do in modern Australia's dry climate. The modern koala is actually thought to have co-evolved with the plants as they adapted to arid Australia. Eucalyptus trees are uniquely adapted to Australia's hot and dry climate, as their leaves contain highly flammable natural oils. They've also evolved so that fires trigger the release of their seeds. They take advantage of the frequent bushfires, and in turn, koalas have evolved to take advantage of the trees. Contrasting with their generalist, longer-snouted, extinct relatives, modern koalas have flat faces that grant them a high bite force for chewing tough vegetation, and have evolved an immunity to the toxic oils of eucalyptus, so much so that they specialized almost entirely on eucalyptus leaves. A completely extinct group of diprotodonts is the family Elariidae. They lived from the Oligocene to the Middle Miocene and are thought to have fed on leaves and or fruit based on the unique form of their molars. The genus Nimbodon from Riversley was superficially very similar to a koala in being an arboreal herbivore that looked a bit like a bear. It's possible they became extinct due to the forest plants they fed upon dying out as Australia's climate dried. A common trend seen in Australia's marsupials is that many of them grew larger as the climate dried and the forests were replaced by more open grasslands and savanna, resulting in what's become known as the Australian megafauna. This has been theorised to have been a result of plants becoming harder to find for herbivores. Larger animals can store larger quantities of energy than smaller ones, making them more efficient for travelling long distances in environments where plants can be hard to come across, such as the outback. This trend is perhaps best exemplified by the next family, the diprotodontids. Whilst often called giant wombats, they are technically not wombats, but rather their own family closely related to actual wombats. This family contained the largest known marsupials to ever live. They were huge, four-legged browsers that are now sadly extinct, and occupied similar niches to placental ungulates and elephants on other continents. Whilst the family appears to be very species-rich, this has been questioned recently, as most were diagnosed by characteristics of their teeth. But more recent studies have shown that diprotodontid teeth display great individual variation. As such, many species may end up being lumped into other genera in the future. The earliest members, such as Neohelos, were modest, sheep-sized browsers living in the dense rainforests in the early Miocene, like those preserved at Riversley. As the forest disappeared and were replaced with more open country, they gradually grew larger, with the largest species, Diprotodon optatum from the Pleistocene, being the largest known marsupial to ever live. Adult males could be 2 meters at the shoulders, 4 meters long, and estimated to weigh around 3 tons. It was exceptional in other ways as well. It was the first fossil marsupial to be named from Australia in 1838, and it is the only known marsupial that seasonally migrated. This is based on strontium isotopes found on fossil diprotodon teeth that show the ratios match those of specimens found in regions differing from those in the region the fossils were found, indicating that the animal fed on plants elsewhere to where it eventually died. They also travelled in large herds of mostly females with a single dominant male, similar to elephants, as is suggested by potential fossilised herds found in southeast Australia. They likewise walked with a gait similar to modern elephants, with straight columnar limbs and ranged across the entire continent. Sadly, these spectacular animals were likely driven to extinction by the habitat destruction caused by Aboriginal Australians some 40,000 years ago, and possibly also from being hunted by them, though there is little to no evidence of direct hunting. The next family, the wombatids, include the actual wombats. Today there are 3 species, the common wombat and the northern and southern hairy-nosed wombats. They're herbivores and live in burrows, which they fiercely defend and have their buttocks reinforced with cartilage for defending against predators when headfirst in their burrows, and will slam attackers into the sides of their burrows with their cheeks. They also have very slow metabolisms, thought to be an advantage in arid environments where food can often be hard to find. Whilst modern species can weigh over 30 kilograms, there are a handful of extinction era, with the genus Phascolinus from the Pliocene and Pleistocene being the largest wombat known to have lived, estimated to have weighed 200 kilograms, if not more, and was probably too large to burrow. The next family is another entirely extinct one, the Palochestids, the marsupial tapirs. They were named as such due to their skulls resembling those of placental tapirs, with a very deep and retracted nasal area, thought to have supported a muscular prehensile lip or even a small trunk, though the former seems more likely, making their marsupial tapir common name a bit misleading. The shape of their lower jaw indicates they had long flexible tongues much like giraffes. The family's type genus, Palochestes, is known from the Pliocene and Pleistocene. Its name means ancient leaper, as when Sir Richard Owen named it in 1873, he thought it was a kangaroo. Due to it being so strange, it is very difficult to discern its ecology. It's been interpreted as a solitary animal due to its rarity in the fossil record compared to other herbivores it lived with. It's also been interpreted as a browser, walking quadrupedally but rearing to feed and using its front limbs with huge claws to either grasp vegetation or perhaps to strip bark from trees. It was a large marsupial, estimated to be around the size of a horse and weighing up to a ton. Interestingly, the earlier genus Palochestes, known from the Oligomycene boundary at Riversley, has shorter jaws, indicating that over time their jaws became more specialised for feeding, but on what exactly is still unclear. Larger herbivores meant that carnivores had to grow larger also. This brings us to the Thylacoleonids, a family of carnivorous diprotodontians. Their exact placement within Diprotodontia is unclear, but most studies place them closer to wombats than to kangaroos. There are some naming clarifications I should make. The common name marsupial lion can be used to refer to either the family as a whole, only its type genus, Thylacoleo, or only the species, Thylacoleo carnifex. For this video, I'm going to be using the broadest definition and refer to all members of the family as marsupial lions. They get this name from their predatory mode of life. Their teeth were unlike any other carnivorous mammal. Most have large, sharp canines for stabbing and piercing their prey's flesh. The marsupial lions, however, had tiny canines and instead used their huge, sharp diprotodontian incisors for this. The dental weirdness doesn't end here though, as their third premolars were enormous, thought to have crushed the windpipe of their prey when they would bite them on the neck, as is similarly suspected of the unrelated saber-toothed cats. The oldest known genus, Microleo, means little lion, and is known from early Miocene Riversley. Its specific name, Attenboroughi, is named after Sir David Attenborough, as thanks for his support in having Riversley listed as a World Heritage Site. As its genus name suggests, it was the smallest member of its family, at around only 600 grams, and was thought to be an arboreal predator in the early Miocene rainforests, hunting small vertebrates. It lived alongside its larger relative, Wackaleo, meaning small lion, which is a bit of a misnomer as species within the genus vary in size quite substantially. Wackaleo species show a trend in increasing body size over geological time. The species found in early Miocene sediments at Riversley, Wackaleo schouteni, formerly its own genus Priscaleo, was named in 2017 after paleoartist Peter Schouten, whose fantastic work you will have seen plenty of in this video already, I'm sure. It's been estimated as weighing about 23 kilograms and thought to have been a semi-arboreal predator that spent more time on the forest floor than Microleo. The later species, W. vandelurei, known from late Miocene sediments, was larger, estimated to be roughly 30 kilograms. This family terminated with the final and largest genus in the Pliocene and Pleistocene, Thylacoleo, meaning pouch lion. Estimated at over 100 kilograms and comparable in size to a lioness, T. carnifex was the largest carnivorous marsupial known. Being much larger than its older relatives, it was thought to have spent much more time on the ground. Its limbs were stocky and heavily muscled, suggesting it wasn't a fast runner and instead an ambush predator. It is still debated whether it would have ambushed prey from the ground or whether it would climb trees and wait for unsuspecting prey to walk underneath and leap down onto them, similar to a leopard. When it grabbed its prey, it likely used its powerful arms to hold on whilst it reached for the neck. unique. It was a truly unique carnivore, and there exists no modern analogue. It was likely an apex predator in Ice Age Australia, though it likely faced steep competition from non-mammalian predators. The giant goanna, Varanus priscus, or Megalania, and the huge terrestrial crocodile, Quencana. It is still heavily debated what caused the extinction of the marsupial lions. Potential causes include climate change driven by Ice Age glacial cycles, habitat destruction by early humans, and or being outcompeted by humans in hunting their preferred giant herbivore prey, or perhaps they died out as a result of their prey becoming extinct. It could be a combination of some or all of these, or perhaps something else entirely. What is known is that ever since the extinction of these predators, no other carnivores have gone on to occupy their vacant niche, with the only potential candidate being the invasive dingo. A very obscure family is the Wynyardidae. Researchers are not confident about their relations with other marsupials, but they resembled possums, perhaps forming a kind of transitional form between the more wombat-like diprotodonts and the more possum-like species, dated back to the Oligocene, spanning across the country from Queensland to Tasmania. Now we have the phalangeriforms, the possums. Possums are not to be confused with the opossums of the Americas, which, whilst also marsupials, are members of the orders Ameridelphia and are thought to have branched off long before the evolution of Australian marsupials. Australian possums can therefore be seen as true possums. Today they are a very diverse group of arboreal foragers, many of which having prehensile tails. The oldest Australian possum fossils are dated to the Oligocene epoch, but not from Riversley in Queensland, but the Galeston Bay fossil site in Tasmania. These were assigned to the family Burrowmyidae, containing the pygmy possums, who have diets ranging from insects to nectar. The closely related family is the Phalangeridae, which contains the brush-tailed possums and the cuscuses. These are among the largest and most successful of the possums, perhaps thanks to their generalist omnivorous diets. The genus Arcturus is known from early to middle Miocene sediments at Riversley, and may have branched off before the brushtails split from the cuscuses, yet already had their generalist diet. An entirely extinct genus of possum is Ectopodon. Several species are within this genus, the oldest of which, E. sturtoni, were found in the Etodunna Formation in South Australia, which date to the late Oligocene. Its teeth were completely unique among marsupials, with their molars being very tall but flat and ribbed on the crowns. It has been suggested this was for eating seeds, and this specialisation may have led to their extinction in the Pleistocene some 700,000 years ago. As for the other possum families, there are the Pseudochiridae, the ringtail possums, the Potoridae, including the triox, and many species of gliding possums, along with the Acrobatidae, the feathertail possums, which are also gliders. Another example of marsupials convergently evolving with placentals, like flying squirrels. These three families each have representatives found at Riversley and other Oligomycene sites across Australia. The last possum family is the most mysterious, the Tarcipedidae. It has only one known species, living or extinct, the Nullbenger, or honey possum. Weighing less than 10 grams, it uses its long sticky tongue to feed on the nectar, or honey, of flowering plants like Banksia, and is an important pollinator for them. No fossil relatives are known, making it difficult to discern when it branched off from the other possum families. The last major group of diprotodonts are the macropodiforms, the Potongs, Potoroos, and Kangaroos. Genetic studies have found that they may be nested within phalangeriforms, which would mean there is no such thing as a possum or kangaroo in a cladistic sense. The family Bulburidae represent basal macropods, contrasting with the large two-legged hopping kangaroos of today. Genera like Bulbaroo were quadrupedal arboreal browsers. The species Bulbaroo fangaroo is named after the group's distinctive canine teeth, earning them the common name fanged kangaroos. They lived from the Oligocene to the Middle Miocene, with their extinction coinciding with the aridification of Australia, which makes sense considering they likely depended on the forests. The family Macropodidae contains the kangaroos, wallabies, wallaroos, pademelons, and the quokka. The early Miocene genus Cucuroo from Riversley is the oldest known member of this family, and was only the size of a small wallaby. It lived alongside the fanged bulburids, and was thought to have been more of a generalist feeder. It's still unclear why, but the macropodids survived whilst the bulbarids died out. Regardless, the aridifying Australia by the late Miocene led to an adaptive radiation in the macropodids, resulting in the familiar hopping kangaroos. With the outback spreading and plants becoming harder to find, macropodids had to change their method of locomotion to survive in their changing island continent. Whether it was an accidental benefit from a repurposed branch hopping ability or an entirely new innovation, the hopping kangaroos were able to cross vast spaces across the flat desert country and saw huge success, filling the niche occupied by hooved placental herbivores like deer on other continents. Their enormous leg tendons make them spring-loaded for hopping, minimizing the amount of energy needed to hop long distances, and their foot bones went from dexterous to rigid, interlocking to prevent them twisting their ankles when they hop. The tree kangaroos of the genus Dendrolagus found in Queensland today are thought to represent a return to arboreality, themselves likely descended from the Pliocene age genus Bora, now extinct, possibly due to habitat destruction brought on by early humans. All modern macropodids are members of the subfamily Macropodinae. There was another subfamily that only became extinct a few thousand years ago, the Stenourinae, colloquially known as the short-faced kangaroos. They appear to have emerged during the mid to late Miocene as Australia's deserts grew. They were the largest macropodids by far, with the species Procoptodon goliath being the largest known kangaroo, standing at over 2 meters tall and weight estimates putting it at around 200 kilograms. They were thought to be so heavy they couldn't hop like their relatives and instead walked bipedally on their back legs. They were thought to be browsers, using their forelimbs to grasp branches and feed on leaves. Their distinct short skulls likely gave them strong chewing muscles for tough vegetation. This also allowed them to avoid competing with their macropodine relatives, who tend to be grazers like eastern grey kangaroos or mixed grazer-browsers like red kangaroos. It's thought that the Stenourines became extinct due to human habitation of Australia around 40,000 years ago, either from hunting or habitat destruction. Another family are the Potorooidae, consisting of the Potoroos, Batongs, and the very recently extinct desert rat kangaroo. They are thought to be most closely related to the macropodids, and similarly are herbivores with jumping back legs. They are unique, however, in that they have a preference for the fruiting bodies of fungi. These both provide a food source during droughts when plants are scarce, as well as allowing them to avoid competing with other herbivores. The extinct subfamily Boulongomyaceae are known from Oligocene Riversley, and their molars suggest they were more generalist herbivores at this time and only later became more specialised for eating fungi. The Potoroos and Batongs are long-snouted and use their sense of smell to find food under the ground to dig out, quite often fungi. They were once so common in Australia that the first European settlers even described them as pests. Now they are sadly endangered due to the introduction of red foxes that hunt them and European rabbits, which have largely displaced them across mainland Australia. The desert rat kangaroo is a tragic case in that it was already rare when Europeans first arrived in the 1840s and was believed to be extinct until being rediscovered in 1931, when a population was found. Over the next few years, however, these animals were decimated by foxes and feral cats moving into the area, with the last recording of the species being in 1935 near Lake Eyre in South Australia, making it the only mammal species to ever be rediscovered by people after believing it to be extinct, to then be deemed extinct again. There is hope, however. A study published in February 2025 has found that the desert rat kangaroo may have had a diet of softer plants than we had assumed. One of their recorded habitats was the Sturt Stony Desert in South Australia. If there are still patches of soft vegetation in this harsh environment, there may just be some desert rat kangaroos still clinging on. We have one last family of diprotodonts to look at, and that is the Hypsiprimnodontidae. Today, there is only one single species left, the musky rat kangaroo, Hypsiprimnodon moschartus, found only in the rainforests of Queensland. Fittingly, fossils of their sister species are found in the ancient Riversley rainforests of the early Miocene. Despite having kangaroo in their name, they don't hop like their macropodid relatives, thought to be a more basal family. Perhaps a more shocking difference is their diet. Unlike their herbivorous cousins, the musky rat kangaroo is an omnivore. Whilst they do eat insects, the majority of their diet consists of fruit and fungi. This is in contrast with their extinct relative. Also found at Riversley in mid to late Miocene sediments was Ecoltodita, colloquially known as the killer kangaroo. Based on its incredibly sharp teeth, it was either an omnivore with a preference for meat or a pure carnivore of vertebrates. The distinct lower diprotodont incisors had been fashioned into an almost shovel-like pair of bizarre saber teeth, and may have been used in a similar fashion to placental saber-toothed cats. Whilst it was only the size of a small wallaby, later in the Pliopleistocene another related genus had evolved, Propleopus. It was larger and still had the huge sharp incisors. The degree of carnivory in this genus is debated, and it may have filled a similar niche to bears as foragers and scavengers, but occasionally hunting. Propleopus only became extinct when humans arrived in Australia, along with many of the other megafauna. Australia's marsupials represent the marvellous power of evolution in isolation for millions of years. These spectacular animals also require our protection. Many species have been driven to or are on the brink of extinction due to human habitation and habitat destruction. It is therefore our responsibility to ensure we can coexist with these wonderful and bizarre mammals. Thank you so much for watching. Please do like the video and subscribe. And tell me what your favourite marsupial is in the comments below. I'd love to hear from you all. Thank you. Bye bye now.